Okay, so let's start. So today we'll solve the assignment 10 for the course linear algebra NOC 23 MA 03. Let's start with the first question. What it is saying? It is saying that consider R3 with the standard inner product, and if three vectors are given, is an orthonormal basis obtained by applying the Grant-Schmidt process to the ordered basis, these three ordered basis on R3. Then is it saying that the 1 0 1 1 1 0 0 1 1 and 3 bases are given, and after Grant-Schmidt orthonormalization we get this. Then you have to find the values of A, B, C and K, right? So let's start. So how to do Grant-Schmidt orthonormalization? So first let's take, let V1 be this vector 1 0 1, V2 be this vector 1 1 0, and V3 0 1 1, right? So what will be then first vector? W1 will be, so after orthonormalization W1 will be V1 by norm V, right? V1 by norm V, V1. So what is norm V1? Norm V1 will be norm V1 square root of 1 plus 0 plus 1, so it is square root of 2. So it will be 1 by square root of 2, 1 0 1. So this is the first orthonormal vector we got. Then for the next vector W2 dash, what it will be? W2 dash, right? So it will be W2 means V2, and you have to remove all the components in the direction W1. So you have to remove, so V2 minus, you have to subtract the means direction of V2 in the direction of W1. So it's V2 inner product W1, and the orthonormal vector of W1 means it's the norm W1 square into W1. This will be the next orthogonal vector. No, orthogonal to W1. This will be the vector orthogonal to W1. So what is V2? V2 is 1 1 0 minus norm W1 is the orthonormal, so norm W1 will be 1, and V2 inner product W1, so this is V2 is this inner product W1 into W1. So if you do this, you will get 1 by square root 2 with inner product with V2 with W1, it will get 1 1 only, and then it will be 1 by root 2, W1 will be 1 0 1, right? So what will be this? So then it will be, so 1 1 0 minus half of 1 0 1, right? So what is this? Will be half 1 minus half. So this is the orthogonal vector. Now we have to normalize it. So W2 will be W2 dash by norm W2 dash. So what will be then this? So if you do this, you will get 1 by 4 W2 dash norm 1 by 4 plus 1 by 4 root 6 by 4 means root 6 by 2, right? So you will get basically 1 by root 6 1, and it will be root 6 by 2, so it will be 2 minus 1. So this will be W2. Now we have to find W3. So W3 dash, so it will be V3, and we have to remove the component of V3 in the direction W1 and W2. So it will be V3 inner product W1 by norm W1 square into W1 minus V3 inner product W2 by norm W2 square into W2. So what is V3? V3 is 0 1 1. So V3 is 0 1 1 minus V3 inner product W1, norm of W1 is 1 and W1 is this, W1 is 1 by root 2 101. So if you take the inner product with V3, what you will get? So it is 1 by 2 will be coming, and V3 with W1 means you will get basically V3 is 0 1 1 and it is 101. You will get 1 and W1 will be 101, right? 101. So you will get this, and V3 with W2 means it will be 1 by 6 because norm W2 is 1. V3 with W2 means you get 2 minus 1, it's 1, and W2 is 1 2 minus 1. So you will get this. So what is this? If you write it down, do the calculation, you will get minus 2 by 3, 2 by 3 and 2 by 3. So this is W3 dash. Now you have to orthonormalize it, normalize it. So W3 will be W3 dash by norm W3 dash. So if you calculate the norm, what will be the norm? W3 dash, it will be 4 by 9 plus 4 by 9 plus 4 by 9. So 3 means 2 by root 3, right? By root 3. So root 3 by 2 so then what you will get? So you will get then 1 by root 3 you will get minus 1 1 1. So you will get this, W3 is this, 1 by root 3 minus 1 1 1, right? So we get 3 orthonormal vectors. So what we have got? So earlier we have this V1, what is this? 1 0 1, V2 is 1 1 0 and V3 0 1 1, and after Gram-Schmidt orthonormalization, we get what we have get? W1 is 1 by root 2 101. W2 we get 1 by root 6 1 2 minus 1, and W3 we get 1 by root 3 minus 1 1 1. So now let's see what we have to find. You have to find the value of A. A is in the 1 0, so A is 1, right? So this is the value of A, right? So what we have got? A equals to 1. So you have got A equals to 1. Next we have to find B. 1B minus 1. What is b? B is 2. This is b. So the value of b is 2. So this is the question number 2. Next, what is question number 3 is you have to find the value of c. So here c is minus 1 1 c. So what is the value of c? So value of c is 1. This is the value of c. So question number 3, the value of c is 1. Now question number 4, what we have to find? Value of k. Where the k is 1 by root k. So k is 3. This is the value of k. So k is 3. So the value of k is 3. So 1 2 3 4 is done. So this is the part of the first question. All 1 2 3 4. Just you have to find the value of a, b, c and k. So this is done. Let's move to the next one. Question number 5. Okay. What did it say? Let B be a finite dimensional inner product space. Which of the following statements are true? The first option is, if B1 up to Bn is an orthonormal basis of B, then for any vector x in B we have, means for an orthonormal basis x can be written in this form. So this is true. Let's prove this. So option number 1. Okay, so a orthonormal basis is given, V1 up to Vn is an orthonormal basis of V. And then you have to write any vectors in terms of this. So what will be the expression? So if x belongs to V, then as V1 up to Vn is a basis, you can write, so which imply x can be written as a linear combination of V1 to Vn, right? C1 V1 plus C2 V2 plus dot 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 C and Vn for some C1 up to Cn, right? These are all real numbers. So this you can write. Now you have to find the coefficient C1 up to Cn. What will be the coefficient? So what is given? Given that V1 up to Vn are orthonormal, right? So let's take inner product with V1. So let's take x inner product with Vi. What you will get? So it's C1 V1 plus dot 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 plus Cn Vn. Sorry, this is Vn. With Vi you have taken fix an I, and we are doing this. So what you will get? So Vi is, as this is orthonormal, so it is, so what it will be? It will be C1 V1 comma Vi, right? Plus dot 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 Ci, it will be Vi plus dot 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 Cn Vn comma Vi, right? And as these are orthonormal, all these are 0, so 0 plus dot 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 0 plus only it will remain, and Vi inner product Vi, because they are orthonormal, so this is 1, Ci into 1 plus dot 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 0 plus dot dot dot, and all are 0, right? So what you will get? This is Ci, and this holds for all I, right? This is true for all I equals to 1 to n, right? So you get Ci, you will be inner product x inner product with Vi. So you get the coefficient. So therefore, how you can write as x is C1 V1 plus dot 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 Cn Bn. So it will be X inner product with V1 plus dot dot dot, it will be X inner product with Vn, right. So this you can write X inner product Vi I equals to 1 to n, right. So this we have to prove. So the first option is correct. If this is an orthonormal basis, then X can be written as like this. Okay. So let's now move to the next option. The orthogonal complement of any set in V is a subspace of V. So it's saying that orthogonal complement of any set will be subspace of V. This is again true. So let's prove what is orthogonal complement. So let V be any set. So what will orthogonal complement? This is V parp, it's called, or orthogonal complement of V. How it is defined? All such W in V such that it will be inner product V inner product W is 0 for all V in V, right. So this is the orthogonal complement. Of V, right. Now you have to prove this V parp is a subspace. So we will show that V parp is always a vector subspace of V. No, sorry. So V is not for any set. Sorry, here I have written. Let V be a vector space. So vector space is the V, and suppose this is, and let W be any set. W be any set in V, then this is the W parp. So this is all vector in V for which this is true, W. So this is the orthogonal complement of W, right. So we will show that this W parp is always a subspace of V. Right. So how to show? First we have to check that 0 vector is is there or not. So note zero, or you can write like this: V inner product 0 is 0, right, for all V in V, right. So 0 vector is there. So therefore V inner product 0 is 0 for all V in also W, because W is a set in V, which implies 0 is in the 0 belongs to W parp, right, because 0 is perpendicular to all the vectors in W, means 0 is in the W parp. So the 0 vector is in the W parp. Now what? This is the first condition. Now what is the next condition? You have to check, let W1 and W2 two vector. W2 you have to check the sum is also in the there. So W1 and W2 is there, means V inner product W1 is 0 for all V in W, right, and V inner product W2 is also 0 for all V in W. So now we have to take this V inner product W1 plus W2, and inner product is linear, so it will be V inner product W1 plus V inner product with W2, so which is 0, right, for all V in W, which implies W1 plus W2 belongs to W park, right? So this, the second condition also satisfies. Now the next condition we have to take. So let W is in W park and a scalar C be the real number. Then you have to check the C times W is also there. So V into C W means, so C will come out from the inner product by the linearity, so it will be V W, and as W is in the W part, so this is 0, right, for all V in W, so which implies CW is also in the W part. So therefore W part is a subspace of V. Is a subspace of V. Okay, so the second option is also correct. The orthogonal complement of any set in V is a subspace of V. Okay, now let's check the next option. For V, here the V is vector space is the R3, and the set is, or which is an orthonormal, saying that orthonormal basis with respect to the standard inner product. So you have to check this is the orthonormal basis or not. Okay, so let's check. So this is option number 3. What is the set given? So R3 is the vector space. What is the set? 1 by root 3, 1 minus 1, 1, 1 by root 6, 1, 2, 1, 1 by 2, minus 1, 0, 1. Right. So you have to check this is an orthonormal basis or not. So first check that these vectors are orthonormal or not. So let's call it B1, B2, B3. So you can easily check that B3 is not orthonormal. So let's find the norm of B3. What will be the norm of B3? It will be 1 by 4 plus 0 plus 1 by 4. Oh, sorry. So this is so this is 1 by 2. So this is not orthonormal, right? So this is norm is not equals to 1. So this is not orthonormal, which implies B3 is not orthonormal. So the option number 3 is not correct. So this is false. Now what is the next? If S, which is set B1 up to Bn, satisfies the condition Vi inner product Vj is 0 for all I not equals to j, then the set S is linearly independent. So let's see. So option number 4, what it is saying? A set S is given B1 up to Bn. This is a subset of V, and what is given? Vi inner product Vj. So this is 0 for for all I not equals to j, right? Then you have to say S is linearly independent or not. So note that note 0 vector is orthogonal to all the vector, right? Note 0 is orthogonal to all the vectors. So if 0 is in S, then the condition is also satisfies. Then the condition star is also satisfied. But as 0 belongs to S, so S is not linearly independent. But as 0 belongs to S, therefore S is not linearly independent. Right. So S may not be linearly independent. Suppose 0 vector is in S, then S is not linearly independent. So therefore option number 4 is false. Okay, question number 5 is done. Let's move to the question number 6. Okay, what it is saying, let H be a subspace of a finite dimensional inner product space V over R, and V belongs to V, then which of the following statements are true? So H is a subspace is given, right? So first option saying that if V belongs to H intersection H perp, if and only if V is 0, right? So V belongs to H intersection H perp, right? Means V is in H and B is in H perp. So B is in H also and B is in H perp also. So and if B is in H and something is in H perp, so they are orthogonal. So means B inner product B is 0, right? So which implies norm B square is 0. So therefore B is 0, right? And so this is one side. So if B is in the H intersection H perp, then B is 0. So this is this side. And if 0 B is 0, then 0 as H is a subspace, which implies 0 belongs to H, right? And H perp is always a subspace, as H perp is always a subspace, implies 0 is also in H perp. So therefore 0 belongs to H intersection H perp. So we have to both the direction. If B is in H intersection H perp, then B is 0, right? So the first option is correct. Now what is the next option? It is saying that H union H perp is the whole B, right? So let's check this. It is saying that H union H perp is whole B. So is this true or not? So this is not true. Suppose in R2 you take this. So this is the x-axis and this is the y-axis. So if you take the x-axis, so this is R2, right? So what is the orthogonal complement of the x-axis? It is the y-axis, right? So but they are not, union is not whole R2, right? So therefore this is not true. So on R2 take H to be the x-axis, means x comma 0 and x belongs to the real number, then what will be the h perp? Then h perp will be the y axis, right? All the vectors which are orthogonal to x axis. So h perp is 0 comma y, or y belongs to R. But is their union will be, but h union h perp is not equals to the whole R2, right? Because 1 comma as 1 comma 1 is in R2, but 1 comma 1 does not belongs to h union h perp, right? Because this type of point is not there, 1 comma 1, it is not in the union of x and y axis, right? So that's why this is not true. So option 2 is false. H union h perp is not the vector space V, right? Now what is the next option? Saying that so yes, it's fine if h union h perp is not fine, then is the span of h union h perp is V? Yeah, this is true. So we'll prove this, that h union h perp may not be V, but the span of h union h perp will be V, right? So let's prove this. So you will prove that span of h union h perp is V. So first note that H is a subspace and H perp both are subspace, as H subset of V and H perp is also subspace of V. So therefore H union H perp is a subset of V. So which implies span of H union H perp is also a containing V. So this proves the one direction. So this is the first direction. Now I have to prove the other direction. So let's prove the other direction. So what we have to prove, that we have to take any vector and we have to show that this is in the span of H union H perp, right? So first you have to show that. So let's take, let V is in B. So you have to show that this is in the span of H union H perp. Let me also let V1 up to Vk be and basis of B, basis of H, right? So let this be an basis of H. Now extend it to the whole basis of V. Now extend it to the basis of B. So let's say V1 up to Vn, right? So this is the basis of V. Assume that dimension of V is n, right? Now use the Gram-Schmidt orthonormalization and orthonormalize this. So now applying Gram-Schmidt orthonormalization, we get what you will get, W1 up to Wk plus 1 to dot 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 wn, right? So this we will get ortho, or after orthonormalization we will get this, right? So what is, so B1 corresponds to W1, right? Or after Gram-Schmidt, right? B2 corresponds to W2 dot dot dot, Bk corresponds to Wk dot dot dot, Bn corresponds to Wn, right? So as B1, B2 up to Bk is the basis for H, so as B1 up to Bk is a basis of H, therefore W1 up to Wk will be orthonormal basis of H, right? And up, as in the Gram-Schmidt orthonormalization, all the vectors are mutually orthogonal. Also, in the process of Gram-Schmidt, we get that all the vectors are mutually orthonormal, right? Orthogonal. So therefore the remaining vectors Wk plus 1 of dot 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 Wn, they will belongs to the H part. That means they will perpendicular to all the vectors in H, right? And now V belongs to V. Now as V belongs to V, so therefore you can write V, you can write some C1 V1 plus dot 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 Cn Vn, right? And so this writes Ck Vk plus Ck plus 1 Vk plus 1 plus dot 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 Cn Vn, right? And up to V1 up to Vk, this you can write some D1 W1 plus dot 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 Dk Wk plus Dk plus 1 Wk plus 1 plus dot 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 Dn Wn, right? And here this up to this belongs to H and this belongs to H part, right? So therefore, which implies B belongs to the span of H union H part, right? So which implies B is subset of span of H union H part. So let's call it 2 and this is 1. So from 1 and 2 we get, so from 1 and 2 we get B equals to span of H union H part, right? So the option, so this option number 3 is correct, right? Okay, now what is the next option? B as an orthonormal basis, right? So this is also true, B as an orthonormal basis. Option number 4, as B is finite dimensional, as B is finite dimensional, inner product space, so B always has a basis. And now use Gram-Schmidt and then orthonormal it. Then applying, let's say this is beta, applying Gram-Schmidt orthonormalization, to beta, we get the orthonormal basis of an orthonormal basis of B. So B always has an orthonormal basis. So option number 4 is also correct. What is the next? H perp is a subset of B minus H. So let's see option number 5. It's saying that H perp is a subset of B minus H. Is this true or not? So this is not true. Again, take on R2, take H to be the x-axis, x comma 0, right? So this is the x-axis. And then what will be the B minus H? B minus H will be the remaining of the x-axis, right? So note that. And what will be the H perp? H perp is, so this is 0 comma y, right? Y belongs to R. So then note 0 comma 0 belongs to H perp, but 0 comma 0 does not belongs to R2 minus H, right? So therefore this is not true. Therefore H perp is not subspace of B minus H, right? So option number 5 is false. Now option number 6 is saying that B minus H is a subset of H perp, right? So this is also not true. Take the same example as 6 question number, B minus H subset of H perp. Is this true or not? So take the same example on R2, H to be the x-axis, x comma 0, x belongs to R, and then what will be the H perp? H perp will be 0 comma y, y-axis. So then note that then 1 comma 1 belongs to B minus H, right? Or R2 minus H. But 1 comma 1 does not belongs to H perp or in the y-axis, right? So therefore B minus H is not a subset of H part. So this is also false. So option number 6 is false. Okay, so question number 6 is done. Let's move to the question number 7. Okay, what is this? Let B be a finite dimensional inner product space and A and B are subsets of B, then which of the following statements are true? It's saying that A subset of B if and only B part subset of A part, right? So this is not true, means the one sided is true. So this is true. If A subset of B, then B transpose subset of A transpose. So this is true, right? This is the first direction. This we can prove easily, right? So let X belongs to B part, right? So which implies X is orthogonal to all the vectors B, say that B is in B, right? Which implies X is orthogonal to all the vectors in B, which is B is in A, right? Which implies X belongs to A part, right? So therefore B part subset of A part. So this side is true, but this side is not true. But converse is not true, right? So let's see the counter example. So on R2 take 2 points, take A to be take this minus 1 comma 0 and B you can take 1 comma 0, right? You have taken 2 points. Then what will be the A part? So this is on R2, sorry. On R2 we have taken 2 points, minus 1 0 and 1 0, right? So what will be the orthogonal complement? Then A part will be y axis, right? 0 comma y, so that y belongs to in R, and also B part will be same, right? 0 comma y, so that y belongs to R. So therefore A is not a subset of B, but B part is subset of A part. Actually here they are same, right? So the option number 1 is not true. This is not if and only, one sided is true. So this is false. Now what is the next option? For any set, any subset S in B, we have dimension of S part plus dimension of S part, the whole part equals to dimension of B, right? So this is option number 2. For any set S, dimension of S part plus dimension of S part whole part equals to dimension of B. Okay, one theorem was done in the class that for any subspace, so this was done in the class as done in the class. for any subspace W, for any subspace W of V, dimension of W plus dimension of W parp equals to dimension of V, right? So this was done in the class, and we have seen that S parp is always a subspace, as we have seen earlier. That S parp is always a subspace of V. So here take W equals to S parp, then what you will get? Dimension of S parp plus dimension of S parp whole parp equals to dimension of V, right? So this we have to prove. So the option number 2 is correct. Now option number 3, this was done in the class. It is saying that that Vp the projection of V onto the vector space W. Then for any other vector in W, the norm of V minus Vp is the minimum among any other vector in W. So the projection of V onto W will be give the minimum, means the minimum value will minimum. So this is a distance, minimum distance will be attained by the projection of V onto the W, right? So this is done in the class, that this is correct. So option number 3, it's done in the class. Now let's check option number 4. If W is subspace of V, if and only if W equals to W parp whole parp, right? So let's check this. W is a subspace of V if and only if W equals to W parp whole parp, right? So this we have to prove. So the this side is trivial, right? As W parp whole parp is always a subspace, right? And this is equals to W. So therefore W, which is the W parp whole parp, is a subspace of V. So this side is trivial. Now we have to prove the other side. You have to assume that W is a subspace of V, and you have to prove W equals to W parp whole parp. Let W is a subspace of V, right? So you have to show W equals to show W equals to W parp whole parp, right? So let's take, let V belongs to W. So which implies V belongs to W means, so V is orthogonal to W parp, right? V is mean orthogonal to all the elements which are in the parp. And what is W parp? W parp is all the vectors W in V such that V in a product W is 0 for all V in W, right? So this is W perp. And what is W perp whole perp? W perp whole perp is U in V such that, so this is U inner product, U inner product W is 0 for all W in W perp, right? Now as V is in W perp, so V is in W perp means, so W perp contains all the vectors U which are orthogonal to W perp. So if called by star and the definition of W perp, V is in the W perp whole perp, right? Because V is orthogonal to W, all the elements which is in W perp, right? So this is in the W perp, therefore W is a subset of W perp whole perp. Now you have to show that this is equal, right? Now what we know, we also know that V can be written as W direct sum W perp, right? As W is a subspace, right? So if you take this, you can write W perp direct sum W perp whole perp, right? This you can also write, instead of taking W, you can take W perp. So therefore dimension of W plus dimension of W perp equals to V, dimension of V, and also dimension of W perp plus dimension of W perp whole perp is dimension of V. So from here you can see that dimension of W is same as dimension of W perp, right? So you can see that W is a subset of this and subspace of this, and the dimension is same. So therefore they must be same. W equals to W perp whole perp. So this proves the option number 4. So option number 4 is correct. Okay. So question number 7 is done. Now move to the question number 8. What is it? Consider the M4R set of all matrices of 4 cross 4 matrices, and the inner product is given. A inner product B is trace of S transpose B. Then a set is given S. You have to find the dimension of the orthogonal complement of that subspace, of that set S, right? Orthogonal complement. You have to find first orthogonal complement, and then what will be the dimension of that subspace, right? So S perp will be, what will be the S perp? All such matrix B in M4R such that A inner product B will be 0 for all A belongs to S, right? S is basically the all symmetric matrices Aij equals to Aji. Right, you have to find the orthogonal complement of the set of all symmetric matrices. So let's take, let A belongs to S, so therefore how A will look like: A11, A12, A13, A14. It will be again same, right, because this is symmetric: A12, A22, A23, A24, A23, A33, A33, A34, sorry, A32. Sorry, I have written it wrongly. It will be A13. It will be A22, A1, A23. It will be A33. And it will be A34. It will be A14, A24, A34, A44. So this is a matrix in S. Now let's take, let B is in the S part. So B we take matrix B11, B12, B13, B14, B21, B22, B23, B24, B31, B32, B33, B34, B41, B42, B43, B44. Now let's compute the inner product of A and B. So first take the A transpose B. What will be the A transpose B? A transpose B. So A is, as A is symmetric matrix, A and A transpose will be same. So let's write it. It will be A11, A12, A13, A14, A12, A22, A23, A24, A13, A23, A33, A34, A14, A24, A34, A44 with B. B11, B12, B13, B14, B21, B22, B23, B24, B31, B32, B33, B34, B41, B42, B43, B44. So if you compute this, what it will be? So we just only need the trace mean the diagonal element. So I just only write the diagonal element. So what it will be? A11, B11 plus A12, B21 plus A13, B31 plus A14, B41. The next element it will be A12, B12 plus A22, B22 plus A23, B32 plus A24, B42. Next it will be A13, B13 plus A23, B23 plus A33, B33 plus A34 B43, and this last element it will be A14 B14 plus A24 B24 plus A34 B34 plus A44 B44, right? So the other elements are there. We have only write the diagonal elements. So what will be the trace? So trace of A transpose B will be sum of all this. So A11 B11. You can take this A12 is common there. So you can take A12 B12 plus B21 plus A13 here is also, so B13 plus B31 A14, you can take it will be A14 plus B41 plus A12 it's done A22 B22 plus A23 B23 plus B32 plus A24 B24 plus B42 plus A13 is done, A23 is done, A33 B33 plus A34 will be B34 plus B43 plus A44 B44. Now it is in the S complement means so if B belongs to S transpose implies A inner product B will be 0 for all A in S, right? So if it is, so therefore, so this is star, therefore star is true for all A belongs to S, right? So if this is true for all A means all A matrix for in symmetric matrices means this the B11 B12 plus B21 this should be 0, right? Otherwise we can always take some elements so that this will not 0. Therefore the term which conclude B means this should be 0. So therefore thus B110 B11 B22 B33 B44 all should be 0, and if this is 0 means yes.
Sir, repeat again.
Okay. So suppose what is the meaning is in the parp S parp means A inner product B is 0 for all A, right?
Okay.
So this means this should be 0 for all the elements A. Means therefore
Okay.
B11 this B12 plus B21 should be 0. Otherwise you can always take some matrix which has A12 is non-zero. Then A trace will be non-zero, right?
Okay.
So if this is true for all A means B11 B12 plus B21 should be 0. B13 plus B31 should be 0. Otherwise you can always construct a matrix for which the trace will be non-zero, right? So therefore all, okay. So if this is 0 B12 plus B21 means B12 equals to minus B21. So therefore B12 will be minus B21. Similarly what it will be B13 plus B31 0 means B13 will be minus B31. B13 will be minus B31, right? So similarly what you will get B14 will be minus B41 B23, you will get minus B32, B24 will be minus B42, and
So B will be skew symmetric matrix another.
yeah,
Again.
B will be so orthogonal complement of symmetric matrices will be skew symmetric matrices. So therefore from here, so therefore B is skew symmetric matrix. Skew symmetric matrix. Right, and then so S perp is the so S perp is the set of all skew symmetric matrices. And what will be the dimension of a set of all skew symmetric matrices? And dimension of S perp?
8.
No, why? It is n in 6, n into n minus 1 by 2, right?
N into n minus 1 by 2.
Yeah, so 4 into 4 minus 1 by 2. So it is 6. So the answer will be 6. So the dimension of the orthogonal complement of the set of S is equal to 6. Okay, so question number 8 is done. Let's move to the question number 9. What it is saying, let P be a linear operator or linear transformation in which is the orthogonal projection onto the subspace W in a linear product space B, and kernel T denote the kernel of linear transformation T, and RT denote the range of the T. Then which of the following statements are true?
Sir,
Yeah.
Sir, orthogonal projection, please define again orthogonal
Okay,
projection.
okay. Let me define it. So P is a linear operator. It is saying P is a linear operator from V to it's a W. Orthogonal projection means you have to define P, take element V. So suppose first W you have taken a subspace and it is a linear product space. So it has an orthonormal basis. So let W1 up to Wk be an orthonormal basis of W, right? Then what you will, how do you define the orthogonal projection? PV you will take, and you will take this, means V inner product W1 into W1, means you take the W1 direction of V. This is the W1 direction of V, plus how to you will V inner product W2 into W2 plus dot plus V inner product W1 into W1. So this is the orthogonal projection, right?
Okay.
So this
Okay.
is the orthogonal projection. Okay, now what it is saying, that range of P and kernel of P intersection will be the singleton 0. So what will be the range of the orthogonal projection? Range of orthogonal projection, what will be this? Range means what is in the span. So P of B, it is spanned by W1 up to W1, right? So range of P will be the span of W1 up to W1, right? So it will be the span of W1 up to W1. So what is this?
Okay.
So this is W, right?
W.
So range of P is W. Oh sorry, this is Wk, because we have taken K. And what will be the kernel of P? Kernel of P, how it is defined? So all such V in V such that P of V 0, right? So P of V equals to 0 means, So V is in V such that this summation V inner product Wi is 0 for I equals to 1 to k. So if this is 0 and they are linearly independent, right, Wi mean the coefficient should be 0, right?
Okay.
So all such V such that V inner product Wi is 0 for all I, right? I equals to 1 to k. Coefficient must be 0 because these are linearly independent Wi's because they are bases. So V is orthogonal to all the Wi I to 1 to k, means this is the orthogonal complement of W, right?
Okay.
So kernel of P is the W par and range P is the W, and you know that W intersection W par P is always singleton, right?
0.
Yeah, as W intersection W par is singleton, so therefore range of P intersection kernel of P is the singleton. So the first option is correct. Now is this in general true? It's saying that for any linear operator, is this true? Range and kernel intersection will be the singleton 0. So this is option number 1 we have done. It is saying that for projection, orthogonal projection, this is true, but is this true for general linear transformation?
No.
Yeah, can you give some counter example? So it's easy, you can take this. So let me define. So T from on R2 to R2 you can define, right?
We can define, sir, lots of many examples.
Yeah. You can define. So we want, suppose, because these are linear operator, define, send E1 to 0 and E2 to E1. Then what will be the range and kernel, right? Then E1 is in the kernel, right? Because T of E1 is 0.
Dimension of kernel equal to 1.
Yeah, E1 is in the kernel of T. And what is in the range? E1 is also in the range of T, right?
Range of T, E1.
So intersection is not non-empty, right?
Empty.
Therefore range of T intersection kernel of T is not singleton 0. So option number 2 is false. Now it is saying that range of P parp will be kernel of P. Is this true? Range of P parp is kernel of P. You know what is kernel of P and what is range of P. Range of P is W and kernel of P is W parp, right? So what it is saying, option number 3, that range of P parp is kernel of P. Is this true? What you know, that range of P is W and what is kernel of P? It is W parp. So it is true, right? Range P parp is the W parp.
W.
So therefore range P parp means it's W parp, which is the kernel of P. So option number 3 is correct. And what is option number 4? Kernel P parp is range P. Is this true? Kernel P parp is range P. Kernel P parp is range P.
It's again true.
Yeah, because parp of parp is again the same, right?
Yeah, same.
Yeah, for
Because-
subspace. As range of P is W and kernel of P is W parp. So kernel P parp. So it is W part whole part, and this is W we have done for subspaces as done earlier. W is a subspace.
Sir, last assignment we have done this answer, but we did not get the marks.
Why?
We don't know. Actually, there are two options: W part subset of W, and W part whole part equal to W.
Yeah, but for subspace is it true? There it is subspace is given or any set.
Any set there.
Yeah, for set it is not true. We have shown earlier.
Oh.
For subspace
Actually, we
this is
missed the
true.
class.
Okay. So this is true. For any set it is not true.
Oh. Okay.
For subspaces this is true. Here we have proved earlier. Here the fourth option. For W is a subspace if and only if this. So if this is short, W must be a subspace.
Actually, we read the book for a subspace, but we did not read about set.
Okay.
Oh, thank you, sir.
Okay. So question number 9 is also done. Now let's move to question number 10. What it is saying here, the vector space is P3R, set of all polynomials of degree less than equals to 3, and inner product is given integration 0 to 1 pt into qt dt. If ax plus b is an orthogonal projection of this polynomial, what we have defined earlier, orthogonal projection on the subspace P1 of P3, then the value of this. So here V is P3, and how the inner product is defined, P and Q, these are polynomial, right? So PQ, this is the integration 0 to 1 polynomial PT, QT and dt. So if ax plus b is an orthogonal projection of this, so here, so x cube, you have to project x cube minus 1. So p is a linear operator, it's project from P3R to P1R. This is the orthogonal projection. So what will be, it's saying that P of what will be this, x cube minus 1, right? You have to find this. So I write down the formula earlier. What is the formula? X cube minus 1 orthogonal projection. You have to take the orthonormal basis of P1, then you have to write, right? So you have to take, so for that we need the orthogonal base, orthonormal basis of P1. So not, yeah, 1. So P1 of R, so this is the span of 1 and x. Now you have to orthonormalize it. So suppose this is V1 and take this is V2. So W1 will be, again this is the orthonormal is 1. And now you have to do W2, right? W2 dash first. So it will be V2 minus V2 inner product W1 by W1 square into W1. Right. So V2 is x minus V2 inner product W1. Let's compute
x. Integration.
What is V2 inner product W1? So it is 0 to 1. What is V2? V2 is x. And W1 is 1 dx, right? So this is half. So this is half and W1 is 1. So this is x minus half. Now you have to orthonormalize it, right? Normalize it. So what will be the norm of W2? Norm of W2 is this square. It will be inner product W2 inner product W2, right? So integration 0 to 1
x minus half whole
square dx. So what is this? X square, or you can expand it.
Whole cube by 3.
Yeah, or you can expand, it will be easy then.
I,
So 1 by 4 dx, then what will be the integration? 1 by 3,
sir, x,
yeah,
x, half of x. It will be not half of x, only x.
why? Oh, so,
X.
yeah, yeah. So it will be
Or
half
plus 1 by 4, plus 1 by
plus
4.
1 by 4 plus 1 by 4, right?
Hmm.
So what it will be? It will be 12, 4 minus 6 plus 3.
6 plus 3.
So it is
1 by
1 by
12.
12. So norm W2 will be 1 by square root of 12.
2 root 3.
Yeah. So W2 is 1 by square root of 12 x minus half.
Minus
Right.
half.
So this is the orthonormal basis.
Basis.
So
1 and 1.
Orthonormal basis of P1 R is 1 and 1 by square root of 2 x minus half. Now you have to write down projection of x cube minus 1, right? So what will be this projection of x cube minus 1? It will be how to write x cube minus 1, sorry, you have to take inner product with 1
1.
into 1 plus x cube minus 1, you have to take inner product
1
with
by
1 by root
1 by
12
root
x minus half into
12 x minus half.
1 by root
1 by root
12
12.
x minus half, right?
Okay.
So this will be again x, sorry, just write down it. So integration it will be 0 to 1
This is
x cube minus 1 dx, and this one 1 by 12 will be come out, x minus half integration 0 to 1 x cube minus 1 into x minus half dx, right?
The whole square.
No, this is in the inside inner product. This is the
Okay,
vector,
okay.
right? So what will be the integration? It will be 1 by 4 minus 1 plus 1 by 12 x minus half. What will be this? 0 to 1 x to the power 4 minus half x cube minus x plus half, right? So this is minus 3 by 4 plus 1 by 12 x minus half, and if you integrate it, what you will get? 1 by 5 minus 1 by 6 minus half plus half, right?
1 by 8, sir. Sir, 1 by 8.
Oh, 1 by 8, right, thanks. 1 by 8, this, so this will cancel up, minus 3 by 4 plus 1 by 12 x minus half, what you will get? 40 minus 3 by 40, right? So minus 3 by 4 plus it will be
60.
60, right?
60.
X minus
Half.
what it will be?
1 by 320.
1 by 320, right? Is this correct? I think there is some mistake. Or is this correct? Oh, sorry, I have written wrong. It will be
Ax plus b.
no, it is divided by the norm, right? So 1 by root 12, it is root 12 it will be, because norm is 1 by root 12, so norm should be divided, so it will be root 12, right? Sorry, here it will be again root 12. So it will be root 12 into root 12. So it will be 12. So then what you will get? 12, here 12, here 12. So you will get basically 3 and 10, right?
Okay.
So 9x by 10 minus 9 by
20.
20. So this is basically 9x by 10 minus, so it will be 20
50.
no 24, 24, right? So it is 9x by 10, 6 by 5.
5.
So this is ax plus b. It is saying that ax plus b is the orthogonal projection. So what is a and b?
9 by 10.
So a is 9 by 10 and b is minus 6 by 5. Then what you have to find? You have to find 10 into a plus b. So then 10 into a plus b. So 10 into 9 by 10 minus 6 by 5. So 10 into, it will be 10, 9 minus 12, right? So minus 3. So the answer is minus 3. Right. Okay. So this is the last question. Okay. Okay. The assignment 10 is done. Is this fine?
Okay.
Okay then. So let's stop for today.
Thank
We'll
you.
meet in the next class. Okay, bye.
Nice.
Bye.